Okay, Math 9, so here is your video on improper and mixed fractions. So our workbooks are split up into section 1.2, which is fraction basics, and we covered everything from the last three videos. So getting fractions into decimals, and then equivalence and comparison, and now here we are looking at converting from improper to mixed. All of those three principles will help us when we get to section 1.3, which is adding and subtracting of fractions. So here we go. Originally, we discussed proper fractions, which were fractions that looked like this, and like this, and like this. And all of these have smaller numerators than they have denominators, which means they're all in between 0 and 1. So the ones below here, you'll notice the numerator is larger than the denominator. Here, 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 and then obviously here. So what this means is that we have more pieces than we need to create a whole, right? Because the denominator is the size our 1 has been broken into. So in this case, if 1 was that size, right? This one was broken into 4. And we have 11 pieces, which means we're easily going to fill this thing up. We're probably going to fill up more than 1. So an improper fraction is just a fraction that can be written as a combination of a whole number and a proper fraction, which is what we call mixed, which we'll look at in just a minute. First, we're going to look at how do we discern and look at improper fractions, both visually and then mathematically. So here's a visual representation of 8 over 3. First, we need to consider the fact that our 1 in this case has been broken up into pieces of size 3. So I have 3 blocks set aside, which means I have 1 plus 1 plus 1, which means I have the potential to have 3. But we need to see how many of these spaces we fill up with 8 pieces. So let's just fill up 1, 2, 3, 4, 5, 6, 7, and 8. So there we filled up 8 pieces of size 3, which means 8/3, right? And what do we have? Well, we have one whole, we have another whole, but then we don't have one. We only have 2 out of 3. So what does this mean then? It means we have 2 and 2/3. So that is the mixed fraction equivalent, which we'll look at in a couple slides. But visually, that's how we look at what an improper fraction is. You can see that we have a full 1 and a full 1. That's why they're improper, because if it was a proper fraction, we wouldn't see that, right? So here's 11 over 4. Well, we have 1, 2, 3, 4, and now we have 4 more, so I'll just do this. Now we have 8. 4 and 4 is 8, and then 9, 10, 11. So you can see that we have more than 2, but we don't yet have 3. So in this case, we would have 2 and 3/4, right? So that's what an improper fraction means. It just means we have more than 1, sometimes more than 2. You could have more than 3. It depends on how many pieces you have in the numerator. So doing it visually like that and converting into a mixed fraction can be tedious and just a little time consuming. So we need to consider the fact that what improper fractions mean. Remember that this line means 12 over 5 or 12 on 5 or 12 above 5 or 12 out of 5, but it also means 12 divided by 5. And what 12 divided by 5 means, it means 12 divided by 5. Now here we are into division again, but this time we look at the fact that, okay, 5 goes into 12 twice with a remainder of 2, which means we have, if we have 12/5, we have 2 here, and then 2 out of 5, because there's our remainder, right? 2 out of a possible 5. So 8 over 3 means 8 divided by 3. Well, 3 goes into 8 twice with 2 remainder again. So now we have 2 and 2/3. The denominator never changes. The denominator is the denominator from the improper fraction because those are the sizes of our pieces. If you have 21 divided by 10, well, 10 goes into 21 twice with 1 remainder. So we have 2 and 1/10. And then 7 over 4 is 7 divided by 4. 4 goes into 7 once with a remainder of 3. So we have 1 and 3 out of 4. So that is how we convert from improper to mixed with the concept of division and remainder. So what about a mixed fraction? Well, if you look at this, you might say, okay, I have 1, 2, 3, 4, 5, 6, 7, right, of what size? Well, how many make up a whole? 1, 2, 3, 4, 5. So I have 7/5. Great, but that's improper fraction. How can you look at this and tell me what it is as a mixed fraction? Well, yeah, you have 7, but you also have this 5 here. This 5 is a 5 out of 5. You have a whole, so you have 1, and then you have 2 out of 5. So 1 and 2/5. So visually, you can read an improper fraction or a mixed fraction, depending on how you want to look at it. So how do we draw this? Well, again, we have 3 wholes. We have pieces of size 4. So here you can see we've split our 1 into 4s. So that's the correct representation. And all that means is we have a full one, a full one, a full one, and then just 1. Okay, right? So if you wanted to convert this into improper now, you would just count them up. But that's what that looks like visually. 3 full wholes, right? It's 1, 2, 3, and then just the 1 of a possible 4 in the last one. So how do we switch from an improper to, or a mixed to an improper in the quick way? Well, think about this slide here, right? We had 3 full ones, which means if you think about them as individual pieces, how many are in each one? Well, 4, 4, and 4, and you would be adding those together. But repeated addition is simplified by using multiplication. We just do 3 times 4, or 4 times 3. So look at this. We take our denominator and we multiply it by the numerator because we have 3 complete pieces of size 4, which gives us 12 pieces. But then we have 1 more piece, so we have to add that piece, 12 plus 1. So it means we have 13 pieces of size 4. So look at this next one. We take our 7, we multiply it by 5, we get 35, and then we add the 2 more. So we get 37 of size 7. Now, a quick little aside here, negative fractions. If you have a negative fraction, remember that a negative is just a quantity, and the quantity is the same. If I had 4 of something, I had -4 of something, my quantity is the same. Because if you did this in multiplication, you might be like, okay, well, that's -35 plus 2. And if you're doing your integer work accurately, you're going to be like, well, that's -33. So you'd have -33 over 7. But that can't make sense because if this is a positive quantity, we just determined we had 37 over 7. So how can these quantities be different? They're different because you can't include the negative sign in the multiplication. All you know is that if your mixed fraction is negative, your improper fraction will be negative. And then you don't worry about it after that. So you still go 7 times 5 and you get 35. Then you go plus 2. So you don't get a negative, you just get 37. And you have 37 out of 7, but that quantity is negative. So you add the negative sign after the fact. All right, so that's mixed to improper. Next, we're going to move into addition and subtraction of fractions, where we're going to need common denominators, and we're going to need to convert from improper to mixed when necessary. So all of the tools we've learned in the last couple of videos are going to come in handy, and we're going to use them quite often. So make sure you got these locked down. Thanks so much.